Hello, today we're doing MCAT Concept Check 1.3 from the Kaplan Chemistry MCAT 2025 to 2026 edition book. So we got question 1. The valence electron in a lithium atom jumps from energy level n equals 2 to n equals 4. What is the energy of this transition in joules in electron volts? So if you recall, when we go from one principal quantum number to another, in this case n equals 2 to n equals 4, that's going to be the energy of a photon equation. So we're going to write that down. And in case you didn't know, this number here should be a hint, the Rydberg value. So we're going to write down E equals RH 1 over Ni squared minus 1 over Nf squared. Now this should be familiar to you because we talked about this in the last video. So let's go ahead and do this without a calculator, because in the MCAT we do not get a calculator. So we're going to plug in the value 2.18 times 10 to the negative 18 joules over electrons, right? And then plug in the values here. 1 over n equals 2, so 2 squared, minus n equals 4, so that's going to be our n final, so 4 squared. This is what we're going to plug in to get the answer. We're going to do some estimations since we're not using a calculator to try and get the closest possible answer. Since the MCAT is multiple choice, this would be a valid strategy. So let's continue over here. First thing you want to do is go ahead and combine this. So common denominator, that's going to be 2.18 times 10 to the negative 18 times 3 over 16. 2 squared would be 4, right? This would be 16. You combine the denominators to get this number here. Now, we're going to estimate this and turn it into 2 times 10 to the negative 18, 3 over 16. Then we're going to come down here and we're going to go ahead and multiply this now. So we're going to have 2 times 3 over 16. That's going to give us 6 over 16 times 10 to the negative 18. This can further simplify into 3 over 8 times 10 to the negative 18. Now we're going to go ahead and do this calculation because I don't know if you know how to do that automatically, but I do not. So I'm going to go ahead and do some math here. So we got 3, 8. 8 does not go into 3, so we're going to have a decimal here, 0. Add a 0 here. 8 goes into 30 3 times. That's going to be 8 times 3 is 24. We're going to get 6. Add a 0. Bring it down. 60. 8 goes into 60 7 times. Basic times tables here. So we got 8 times 7 is 56. That's going to give us 4. Another 0 here. And then we have 5, ultimately finishing off this division. So now we got this decimal. To get the answer, we're going to go ahead and multiply it by 3.75 times 10 to the negative 19. To move the decimal over one's place, we add an extra digit from 18 to 19. And that's the answer here. And it should be in joules, right? That will be the answer for this question. If you want to go ahead and take a screenshot, look at it real quick. So we did the first part of the question where we find the energy of the photon in joules. Now we're going to find it in EV. So to find it in EV, we're going to just change this Rydberg number into 13.6 because if you see up here, they are equal to each other. So we're going to go ahead and do that. Plug in the numbers, 1 over 2 squared minus 1 over 4 squared. We're going to go down here. We're going to have 13.6, same as before, 3 over 16. Now we're going to estimate to 14 times 3 over 16. We're going to go ahead and do some math real quick. That's going to equal 14 times 3 over 16. Now if we do some math properties here, you can take out this part right here and turn that into 7/8 times 3, right? That's going to equal to 21/8. Let's do some division because I'm not super good with this memorization off the top of my head. 21 divided by 8. That's going to go into 21 2 times. 16. That should be 5. 8 times 6, right? That'll give us 48. 2. Another 0. 0. 8 goes into 20. I want to say 2 times. 16, 4, and then you have 40. And that's going to be 5, right? So 5 times 8 is 40. So you're going to have about, let's estimate 2.5 electron volts. And that's your answer. All right, so here's number 2. If an electron emits 3 electron volts of energy, what is the corresponding wavelength of the emitted photon? And we have 2 steps to this problem. First thing we need to do is convert electronvolts to joules because joules is what we measure energy in. Now conveniently they gave us a conversion here, so the first thing we need to do is convert. So 3 electron volts times 1.6 times 10 to the negative 19 joules over electron volts. Remember, you want to cancel out the electron volts here. And we have 4.8 times 10 to the negative 19 joules. This is step number 1. Now, the next part of the question is looking for wavelength, right? So we got an equation for wavelength, if you recall from my last video. E equals Planck's constant times the speed of light over wavelength. So this is going to correlate energy with wavelength. They gave us Planck's constant in case you forgot it. They did not give us the speed of light. So it might be good to memorize the speed of light. 3 times 10 to the 8 meters per second. Now, the next step is to rearrange this equation so that wavelength is on this side. And if you multiply by wavelength on both sides, and you divide by E on both sides, you will get wavelength equals HC over E. Now you just plug in the values, right? So we got 6.626 times 10 to the negative 34 joules times seconds times 3 times 10 to the 8th meters per second all over 4.8 times 10 to the negative 19 joules. Now we can cross out some of these units, I should say. Let's cross out seconds here and joules here. So we're left with meters. Let's round this 6.626 to just 6.6. And let's go ahead and multiply that by 3, right? So we got this 6.6 times 3 here. And now we're going to get 10 to the negative 34 times 10 to the 8th. So we're going to go ahead and do that. We're separating it to make this a little easier. And then you see why, right? So the reason we do that, and this will be all over 4.8 times 10 to the negative 19. And we still have meters in the top. Now we can easily combine these values here. When you multiply, you're adding the exponent. So negative 34 plus 8, that's going to give us times 10 to the negative 26. Now 6.6 times 3. 6 times 3 is 18. 18, 19. Decimal right here. 19.8. So we're going to have 19.8. 4.8 underneath times 10 to the negative 19. Now when you're dividing right here, exponents you're gonna subtract. So that's gonna give us times 10 to the negative 7. So we have times 10 to the negative 7, 19.8 over 4.8. Now we gotta divide this. So you can round here. Let's round this up to 20 over 5 times 10 to the negative 7. 20 divided by 5 is about, I want to say 4. It's not, I want to say, it is 4 times 10 to the negative 7 meters. And that should be our answer. And if you want to get even better with it, right, you're going to go 400 nanometers. That'll be your final answer. All right, here's the final problem. This one's pretty simple. Number 3, calculate the energy of a photon of wavelength 662 nanometers. Same formula as before. E is energy, right? So we're calculating the energy. We want to relate it to wavelength, so we got hc over wavelength. H is Planck's constant. C is going to be our speed of light, which is c is equal to 3 times 10 to the 8th meters per second. So we just plug this in. E is equal to 6.626 times 10 to the negative 34 joules times seconds. We got C 3 times 10 to the 8th meters per second all over. And we got the wavelength is 660 nanometers, which is equal to 6.62 times 10 to the negative 7 meters. So we just did a little conversion there in our heads. Why? Because in the problem we got meters. We got meters and meters, and we can cancel that out. So we're just left with joules, right? So we can cancel out the S's. So now we just have joules. Joules, you always want to do this to make sure you got the right units and everything's good. I believe that's called stoichiometry. So now we're going to go ahead and go down here. Let's estimate this is going to be 6.6. And then down here, if you notice, this is also going to be 6.6. So 6.6 times 10 to the negative 7. And we're going to have this times 3. We're going to separate the exponents again. So we're going to have 10 to the negative 34 times 10 to the 8th. 6.6, these are going to cancel out into 1. So we don't really need to worry about that anymore. So let's go ahead here. Now we got 3. Now let's take a look at this right here. Negative 34 plus 8, like we said last time, we're adding. We're going to have times 10 to the negative 26 all over 10 to the negative 7. Now all you have to do is subtract negative 26 minus negative 7, right? So that's going to equal 3 times 10 to the negative 19 joules. And that will be our answer. Let me zoom out so you can see the whole picture. Hopefully that makes sense, and hopefully it helped.